All right, what you're looking at here is a simple but elegant one-tube AM transmitter, a classic design by Fred Nachbor that dates back to 2003. It's built around a 12BE6 pentagrid converter tube, and while it was originally designed to modulate an audio input onto an RF carrier at around 1 mAh, there's something deeper here, something that links directly to the kind of high voltage, high impedance reactive work done by Don Smith. Now let's zero in on the LC stage at the top right of the schematic. You'll see L1, L2, and a variable capacitor forming a resonant tank circuit. L1 is your main coil, and L2 is tightly coupled over it. It's a sort of mini Tesla coil in function. And notice how the antenna connects right at L2. That antenna, in this case, is acting almost like a third coil, a radiating element, yes, but also a reactive power sink. And here's the key. In Don Smith's systems, he used a third coil in exactly this way, to phase reactive power back into real power by exploiting resonance and field interactions. In this transmitter, what's happening is a beautiful dance of energy. The tube excites the tank circuit at resonance, building a standing wave in L1 and L2. Because the coils are coupled, energy is transferred inductively into the antenna coil, L2. That energy is then radiated as amplitude modulated RF. But more subtly, this configuration enables efficient reactive energy recycling. Just like Don Smith described, when everything is tuned right, the third coil, your antenna, can act like a kind of power reflector, returning in-phase energy back into the tank, reinforcing it, and making the system more efficient than it appears. So, while this is just a transmitter on the surface, it's actually a prime example of field coherence through resonant induction. The high voltage swing at the tank peaks becomes the driver, and the energy loops through reactive fields until it's either radiated or constructively reinforced. And that's why this circuit works. It leverages LC resonance to create a condition where voltage and current are oscillating at the exact right timing, like pushing a swing. The vacuum tube acts like a gate or tickler, nudging the system at just the right moments to keep it ringing. It's a feedback loop tuned to the rhythm of nature's electromagnetism. So imagine this. If instead of an antenna, you loaded that third coil into another resonant tank like Don Smith did, you might just close the loop on a self-sustaining oscillation where high voltage potential becomes real, measurable power on the output side. What we have here in this classic one-tube AM transmitter isn't just a vintage radio circuit, it's essentially a high-frequency resonant driver, very much like the 1MHZ version of the Russian Kappa generator style Don Smith system. The parallel is striking when you step back and look at the core mechanisms at play. At its heart, this transmitter uses a resonant LC tank, L1, L2, and the tuning capacitor to oscillate at a fixed frequency, driven by a tube acting as a power oscillator. This is functionally the same as the high voltage, high frequency tank circuits found in Kappa Gen setups. The role of this tank is to create a standing electromagnetic wave, and when tuned right, it allows energy to be drawn from the reactive fields, what Don Smith often referred to as radiant energy or potential spikes. Now here's where it gets interesting. The Russian adaptation of Don Smith's ideas, seen in devices like the Kappa Gen, focused on powering real-world loads, including inductive devices like motors and transformers. But the problem is LCR tank circuits are extremely resonance sensitive. Connecting an inductive or reactive load directly to such a system tends to shift the resonant point or damp the oscillation altogether. To solve this, the Russians took a clever route. They decoupled the load from the primary tank by using a secondary AM modulation stage. Just like in this transmitter, a small portion, say 10% of the tank energy, is siphoned off to modulate a carrier, not with audio this time, but with 60 Hz sine wave energy. This modulated signal is then radiated or transmitted inductively to another stage, which demodulates or rectifies it back into usable 60 Hz power. Since the modulation process preserves the integrity of the tank's high-frequency resonance, this allows inductive loads to be powered without interfering with the tank's operation. Essentially, they use AM radio techniques as a power isolation strategy. So take a look at this crystal radio circuit. This is basically a perfect example of what we're talking about when we say L3 in the Don Smith setup. You've got your inductor and capacitor forming a resonant tank just like in the transmitter side, but this one's on the receiving end. There's no power supply going into it. It's self-powered, just picking up energy straight from the field of the transmitter and flipping that energy back into phase to drive the headphones, which are a high impedance load. That's real usable power being captured directly through field interaction, no wires, no batteries. Now what's important here is how this circuit works. The diode acts as the phase corrector or demodulator, and because the tank is tuned to the transmitter's frequency, it resonates and pulls energy right out of the surrounding field. This is exactly what Don Smith was doing, but on a much more powerful local scale. Instead of the weak field from a distant AM station, but his systems had strong local fields from high voltage, high frequency tank circuits. So instead of driving headphones like this circuit does, Don used diodes and capacitors, sometimes with a split course setup to correct and transduce that reactive energy into usable output. With enough field strength and the right tuning, it didn't matter whether the load was resistive or inductive, because the load was decoupled from the tank. That's the difference between Don's setup and the Russian-style Kapagin approach, which still relied on modulating a separate output stage. Don skipped the extra modulation circuit and went straight to correction and transduction. Also, pay attention to the ground return path in this crystal circuit. It's the same kind of loopback Don was always talking about when he mentioned earth grounds. It's not just a return, it's part of the resonance, a key to making the field interaction work right. So this little crystal radio, it's the foundation. It's a basic version of what Don Smith built into a high power system. Really just a high voltage AM transmitter and a crystal receiver all packed into one. So let's talk about Don Smith's transducing method. It's actually a pretty primitive and elegant process at its core, but it often gets misunderstood because of how unconventional it looks. Now, if you look at this circuit here, what we're seeing is a textbook demonstration of that exact process done right. You'll notice the input is chaotic, just random high voltage noise spikes, what most would dismiss as unusable. But this is where the magic starts. By routing that raw energy through a properly tuned LCR network like we've done here, we're not just filtering, we're performing what I'd call a time domain correction. That's what Don was talking about when he said you sacrifice time to get real energy out. Think of it like a swing. You're not pushing it hard once and letting it die out. Instead, you're giving it small, high-speed taps at just the right moments. These taps are noisy impulses, build up motion, but the swing, our tank circuit, continues to oscillate at its own natural, slower frequency. That slower, stable frequency, like 60 Hz, is where real power emerges. We're turning chaotic voltage potential into real, phase-aligned current over time. That's the heart of transduction. Now, Don showed this with a simple resistor across the primary of his coils, and that does provide some damping and correction, but through my own experimentation, I've found it takes a bit more finesse. This proper LCR setup, a capacitor to store charge, an inductor to slow down the rise time, and a resistor to shape the Q, actually allows for a full speed correction. You're not just dumping potential, you're massaging it into coherence. Even more important, this plays directly into what Don was doing with his last coil, usually a toroidal setup. That coil, with its tight magnetic coupling and built-in high-frequency rejection, acts like a memory element in a transformer core. It stores the field's shape momentarily, letting it settle and discharge smoothly into the load. That's the transformer memory effect. Not just magnetic hysteresis, but field phase alignment over time. So in the bigger picture, this diagram you're seeing right here, this is the Rosetta Stone of Don's energy method. It shows that if you correct the speed and phase of raw potential using a tuned resonant network, the energy becomes usable. resonant energy transformed into real power ready to run loads. This is the same principle behind the final output stage in Dawn's devices, the power takeoff point where the chaotic field gets slowed down, aligned, and converted. Bottom line, we're not making energy from nothing, we're just harvesting it smarter by letting nature do the heavy lifting, one resonant swing at a time.
Hello all, I just wanted to put some clarification and some notes here before I got into my topic here that I wanted to explain. So I wanted to shed a light first to show people where I was getting at here. So now to continue on the discussion from this point on, there is some research. So it's not like top secret information, but it's information I noticed that is not available basically in the English literature and English forums and that sort of thing. But the Russians, especially with the Kappa-gen setup, were able to make some findings of their own, and they shared it freely in their forms in Russian language. I ran some translators to get some of these key elements, which I believe Don Smith and others have not shared. So again, not that it's something remarkable or a major achievement that I personally made. I just want to share it to help you understand better what it is that me and others are doing here. So with that said, perhaps Don Smith knew this, but he didn't tell anyone. I don't know. But the Russians anyways are freely talking about it. So it's out there. So it's not like I could pretend it's a secret. So I'll talk about it, obviously. So with that said, as you see here, there's more than one thing to be actually able to take the resonant field. So what you're doing is you're building a very strong reactive field. It's a very strong localized field. So you're feeding, you want the high Q essentially to generate on your primary tank anyways, a very high intensity field, a localized high energy density field. And of course, as I've talked about earlier, various ways to deal with that and filter it and transduce it, all right? But everyone knows that Don Smith was running loads like fridges, water coolers, that sort of thing. And as far as the load, as far as the drive was concerned, it was like basically not feeling it. So there was basically an efficiency factor that people are trying to figure out, and they just assume, well, resonance is magic, and it's not magic, and it's not going to give you energy out of nothing. But you could use resonance as a clever energy transfer and manipulation mechanisms. So smart, cleaner way of dealing with the energy. That's already there, by the way. As I've explained, of slowing it down with the transducer, crude transducer method here, as an example. But by doing that, of course, someone would expect naturally, and a lot of people who fail, because they feel that's just all you have to do and that's it. But you need to know very well all the underlying issues and principles going on here. And it's very clear in the Russian literature of those who are apparently claim to have been successful at it anyways. There seems to be a general rule of thumb. Whether they figured this out through trial and error, mathematics, simulations, I don't know. But what happens is, what they're getting at is your primary tank circuit. So basically, never mind the amount of, you could feed it whatever method you want. The whole idea is to generate a high voltage so that you get those very strong reactive fields. So whichever way you want to drive that, so I suggest find out the most efficient method and go with that, whatever you can work with. So essentially, depending on the frequency too, you may not even need a high voltage source to drive it. For example, simple radio transmitters of just a few watts on the right LC tank circuit, just the resonant condition will allow a very high potential buildup just on its own naturally. So if you were to measure even a few watts into a 50 ohm load, a dummy load, essentially a resistor, and measure the voltage, you'd only get a few volts, believe it or not. And that's what, quite a few watts, believe it or not. So what I'm getting at is it's not the raw watts that give you voltage, but once you shoot that into an LC circuit, that'll bring on its own, especially if it's high Q, your high voltage, which will generate the high intensity fields nearby that you need along with the RF, right? So Just doing that on its own, you see, people will say, well, look, the energy has to come from somewhere. What happens is this rule that the Russians will basically keyed in on, and basically reminisces of what I was saying. You just want to sip off the field. You don't want to collapse a fully resonant condition, because as many of people have tried, you'll just end up dampening it. You kill the. So with experimentation, the Russians basically figured out that whatever it is, your primary LC tank, the one that's generating your high voltage fields, as long as your what you would consider your secondary or your coupling is 10% of the length of the first coil, essentially. Okay, very important, 10%, because we're dealing like with antennas. There's not necessarily turns, but naturally, if you get the ratio right, you can figure it out in turns as well. But essentially, 10% of the length of the first tank circuit, which would be very high Q. So your step down obviously would be less turns, but only 10%. The whole idea behind that is they figured out that if you siphon only 10% of that nearby field, as far as the resonance system is concerned, it doesn't get disturbed by that. Remember in earlier videos when I said you could put receivers nearby a field, but at a certain point, that field is going to start collapsing if you use too much of that energy, and that's what you don't want to do. So it's not necessarily an unlimited supply, but more one that's not linearly linked with the transmitter. In other words, the transmitter will put out its maximum efficiency that the LCR tank allows it to put out, whether or not there are couplings nearby. So the transmitter doesn't care whether or not you're collapsing that field later on, if it's properly tuned into the LCR tank that it's primarily driving. So it's up to us to use it efficiently is what I'm getting at. And what happens essentially when you just use 10% of the field energy to excite your secondary system, it doesn't roam. So essentially it leaves the field alone, so you're able to let it build up its resonance and keep the field maintained. And because you're taking 10% of that, it doesn't collapse it. So it doesn't. So not only does the transmitter not feel it, but the actual field dynamics itself don't feel that you're coupling into it if it's resonant and less than 10%. So essentially with that, the frequency matters too. You can't use any random frequencies. Another thing, Don Smith says 21 megahertz. That's a little bit misleading because if you look at the length of the coils and everything he's working with, it's more like 60 megahertz, and I'll tell you why. The Russians, of course, talk about this, and they say that for this to work, like if you're going to slow it down to 60 hertz, the primary frequency has to be 60 megahertz. So at 10%, it's going to give you that energy without siphoning. So essentially what I'm getting at is this is how Don Smith was able to not only run his transmitter efficiently, but whatever his load through the transducer, it was like it wasn't even siphoning it off the battery. This is essentially why. But it was a carefully, the condition that needs to be thought of, and it's essentially 10% is the big number, really. So with that said, frequency has to be 60 megahertz for 60 hertz at 10%. So this way here, your load, which is going to be using 10% of the field intensity, but that once you step it down from the high voltage, this is where the gain comes in. So this is essentially like, this could be like your 1 kilowatt version at 110 volts at 60 hertz AC, but it's not coming out of nowhere. It's because of all the dynamics we have. We're reshaping it, we're slowing down, we're buffering it, and then we're slowly releasing it into higher bursts because we can do that. Essentially, with the whole magnetic mechanisms, we're building the equivalent of a magnetic capacitor that stores the magnetic energy, accumulates it, and then slowly releases it at a resonant, slower frequency. So more efficiency. So essentially, it's that 10%. But again, people then want to do the famous loop it. But And this is where 99.9% of everyone gets it wrong, folks. And essentially, if you're going to try and loop it, I'm going to have to give you a virtual slap on the face for that. Because in this kind of thing here, well, you should know by now from following me, Benini, anyone else, that as soon as you try and close loop the source back into itself, that never works out. Sure, you can charge the source, but it has to come from a decoupled system that's not the primary closed loop. Like an open field dynamic system will then be able to recharge the battery. So with that said, how did Don Smith do it? It was pretty easy. All you have to do, well, he left some hints without clearly saying how it happened, but you could see it in his configuration of his thick wires. The positive and negative go into the battery. It's a little over 30 inches each lead, and he splits them apart on each side. So essentially he forms a real radio dipole with the two thick, and being thick copper not gives it actually gives it a bit of capacitance, which makes, as far as an antenna, more broadband. So the tuning doesn't become so critical. And what I'm getting at is, if you look carefully, he says again it's 21 megahertz, but if you look at the lengths, a quarter wavelength of 60 megahertz is more within the 1 foot to 3 foot range. This is just crudely speaking here, than if you were to, because 21 megahertz, is close to the CB band. And I mean, if you ever look at CB antennas that are a quarter wave or half wave, I mean, these things stand up like 12 feet in the air. So, those would be some pretty massive dipoles, 12 feet. And if you look at the suitcase, it doesn't quite align the wavelength, but if you get into 60 megahertz for 60 hertz, then the sizing, all of it, the scaling matches with what Don Smith was doing. So with that said, the dipole is essentially a radio, crystal radio, and you literally put a diode on the battery, what Don Smith would call, the flyback protection, but because the diode has a dual purpose, it can rectify and basically filter out the negative portion, and which is good because, again, we just want to siphon a bit of that. We don't want to collapse the whole field. So the diode is that non-symmetrical component which allows the battery to essentially field charge itself. This is the feedback Don Smith was talking about, where he goes, well, the batteries, without giving you any details like I have on how it's actually happening, the plus and minus proms feeding the first inverter, which is his AC stage to feed the high voltage, that was a tuned radio dipole that's isolated from the DC pat actually feeding the inverter. So you end up, because of his coils and high voltage, this creates a very strong localized RF field that's essentially decoupled from the primary system. Now you don't want to, so he takes that to create a new EMF, corrects the phase and the speed, and that runs your load. But you don't want to use, you want that to run a separate load. You don't want that to run your battery. So you have to isolate that's the load from charging. What I'm getting at is, in this field, you can't have both running off the same closed loop. So you have to preserve one loop for the load and then another separate loop to recharge the battery. So in this case here, the field dynamics, because we're only taking 10%, there's still a very strong RF field nearby. So not only is your load running at 110 volts and hardly any current as far as the system is concerned, but you're getting super watts out of it, the battery is charging itself from the field dynamic at that frequency, because of the wavelength allows the compatibility at 60 megahertz. Anyway, even 60 megahertz could be dangerous. You have to make sure that it doesn't actually radiate a far field, and you respect the FCC limits, or North American, whatever you are. The final product would definitely require some form of shielding, because you don't want to interfere with radio systems, and this is a radio transmitter slash receiver, maybe a near field version, but it still is, so you got to be conscious of that as well. So for the sake of Don Smith doing a demonstration in the hall, I don't think he really cared that, he put a dead carrier on 60 megahertz, and if someone had a radio maybe up to a mile away, he could have heard that, believe it or not. I've never talked about those dynamics, right? Because, probably would have given away too much of what it was actually doing, and he didn't want to do that. But again, here I am, not actually giving everything away here, just acting as the translator, which is what available already in the Russian literature. And some people on YouTube have already replicated the kappa gen and variants, so no secret there. What we'd like to do is find better, more efficient ways of building things that people, and even down to the roots of Tesla, have done in the past. Well, how can we use technology, AI, to make it better on possibly a commercial scale, which doesn't maybe cost, 200 zillion million to get there, right? So with that said, I'd like to say have a good day to everyone, and hope that I shed the light on all of this. Thank you very much for watching, and have a good day.